So the reason I like this picture, and I'm actually doing a little bit of out of order from where the book has it, but it does a great job of showing how the ATP is actually made, and you can make your comparison with mitochondria here. So if we just really quickly look at this, and we're seeing photosystem 2 and energized electron, and what I want to draw your attention to is the electron transport that's in the middle here, and seeing that the protons are being carried through the cytochrome complex. But anyway, those protons are leaving the stroma, which is the liquid inside of the chloroplast, and they're going into the thylakoid space. And so we're causing this concentration gradient, this proton gradient, to be formed, just like we did in the mitochondria in the intermembrane space. But you can see that we even have ATP synthase being used here. And as this proton gradient builds up, we can use it to make ATP, which again, I don't know, this is just one of those things where I'm like, this is so cool that chloroplasts and mitochondria, they were supposed to have evolved by very different means, in chloroplasts before, or mitochondria before chloroplasts, and whatever. But to see that the mechanisms, even the ATP synthase, works in a very similar way, and that these all, it's an amazing design to me. But anyway, that was the big thing I wanted to point out: is where is this in these thylakoid membranes? How does the ATP get made with the chemiosmosis and all of that? And also just some things to point out, the ATP, when it gets made, it's made on the side of the membrane that's the stroma, so all that ATP is already out there in the liquidy area, and that's where it's going to get used later on. Also, in the end of everything, the NADPH is also made in the stroma, so that it can be quickly taken over to the Calvin cycle, which is going to use these. Our next picture then is going to show one little extra thing that goes on in all of this that is very, very important. What this is showing here is a different way that the photosystems are used. The previous 2 slides ago or whatever, what I showed you had a non-cyclical use of the electrons, the energized electrons. It just means they weren't recycled in any way. This is what we call the cyclical or cyclic electron transport, or the electron movement through the photosystems. The reason this is needed, when we get to the Calvin cycle, we'll find that we need more ATP than NADPH, and what we did with the non-cyclic electron movement, we ended up making the exact same number of ATP and NADPH. So there has to be a way for us to make more ATP. And the way to do that is what's shown right here. We can make more ATP without making any of the NADPH. And the way we do that is when we get our excited electrons in photosystem 1, when they get captured by the primary acceptor, instead of sending them down the electron transport that would make NADPH, we're going to cycle them back to the first electron transport chain, where that cytochrome complex is. And that's the place where the protons get pumped through into the thylakoid space. So we're taking these energized electrons, putting them back into the first electron transport chain, and then if you remember, when they get to the bottom of that electron transport chain, they get dropped into the chlorophyll A P700 in the photosystem 1. So you can have a little bit of a cycle going on here, where the electron from the chlorophyll A in photosystem 1 is going to go back into the electron transport chain that feeds the chlorophyll A in photosystem 1. But what this does is it makes ATP without making the NADPH, and this solves that problem that we would see later on in the Calvin cycle, where there's more ATP made, or needed, I should say, than NADPH. So this happens. There's different triggers in the cells that the book talks about that would trigger this to happen instead of the non-cyclical form. So this is all the information I've got for you on the light reactions. I would expect there to be some questions. There's a lot going on here, and you guys have done great with asking, like, why does this happen and why does that happen questions. So ask away. The next series of videos is now going to take this ATP and the NADPH, and we're going to get some payoff. We're going to actually start to make glucose at the Calvin cycle. So have a good night, and we will see you in class.